Hello, everyone, and a huge thank you for joining us today for a discussion on how to get started with cloud native. This is a lead dev webinar created in partnership with Chronosphere. It will last roughly 45 minutes, after which both myself and the panelists will head over to the lead dev Slack to answer some of your questions in the technical strategy channel. We may also have some time to answer a couple of questions live, so please do submit those through the Q&A feature on Zoom, and we'll get to them if we can towards the end of this session. So let's get started with some introductions. My name is George Hanzaras. I'm a director of engineering at MongoDB, responsible for Kubernetes, and I'm joined by a panel of really great industry experts. Florian Loretan, Song Park, Lais Oliveira, and Nimisha Astagiri to share their experiences and insights. Let's start with a round of introductions. Florian, would you like to introduce yourself?
Yes. Yeah, so thank you. It's great to be here. So yes, my name is Florian Loretan. I'm based in Munich, Germany, and I'm CTO at Fraud Zero.
Thank you. Next up, Lais.
Hi, everyone. Super happy to be here. My name is Lais Oliveira. I'm Brazilian, but based in Berlin, in Germany. I'm a principal engineer at Nubank.
Thank you. Nimisha.
Hey, everybody. My name is Nimisha Astagiri, also go by Nim. I'm based here in Boston, Massachusetts, although I'm in North Carolina technically today. I'm a technical principal at ThoughtWorks.
Thank you. And Song?
Thanks, George. Song Park. I am based in the beautiful Garden State, which is New Jersey. I head up the solutions engineering team here at Chronosphere. Great to meet everyone.
Nice. Thank you. Thank you all for the introductions. And I think we can just jump into the great questions we have for our great panelists. So I would like to start with Florian. Florian, kind of on your role as a CTO, you see things on a strategic level as well, on kind of the decision making. And we've seen lately a lot of drive in microservices, but also adoption of cloud native tools. And the first question here is, does cloud native drive the need for microservices, or do you see this move towards microservices create the need to adopt cloud native tools?
Yeah, thank you. I think that's an interesting question. It's a bit like the chicken and egg challenge, is like which one came first. And so one thing is clear, there is a correlation, but I think it's difficult to say which one really drives the other. So there, of course, a microservice architecture really makes sense on top of a setup that really makes it possible to create small things, to like really a disposable infrastructure. And this is exactly what cloud native provides. And yeah, so there is definitely a clear interaction there. I think the thing that both cloud native technologies and microservice architectures have in common is the promise of more flexibility. The kind of flexibility that's like, if you need 10 times more resources because of the peak in traffic, you have it. If you just need a new service, a new database, anything like that, your team can create it. And this flexibility, it's supposed to save you cost. It's supposed to give you faster development and so on. Whether it does deliver on these promises, well, it depends. That's something that's not always guaranteed. But I think one of the key challenges, actually, both with cloud native technologies and with microservices, is not whether you use it or not, but actually how you put it all together in one package that actually makes sense for your organization, and really creating a product and an architecture that makes sense for the teams that use it.
Great. Thank you, Florian. And speaking kind of these transformations, Lais, I know you've been in the financial services industry for quite long, and you've moved kind of from more traditional to fintech side. You've seen it all, and I'm sure you've seen this industry move towards the cloud, move towards adopting these type of technologies. what has the role of cloud native been there?
Yeah, this is a really, really interesting question. I think also one of the reasons I think why I really enjoyed going through experiencing all of those changes, joining a startup, what I observed, it was more broadly, I think all this set of practices and technologies helped us just to build better products and offer better services and products for us, everybody, as consumers. Enabling new business to start to generate more competition, and then as a result, just have more competitive services and products for everybody. So I think this was a really, especially if you think about the industries, the more traditional industries as financial industries, you couldn't think some time ago that a new company would emerge to offer financial services very easily. You would have to have, I don't know, all the hardware necessary and to hire the big consulting companies to do everything that has to be the same. So there wasn't a lot of space for innovation. So I think it was really amazing what happened in the industry to just enable new business to start, and in the end, everybody benefits from it just by having better products and more competition. Yeah.
Okay. Thank you, Lais. And as this shift happens, I've seen kind of observability playing a central role, both in kind of being one of the biggest transformations you need to do, but also it's a central point where you can actually watch and observe how everything happens. And one of these transformations is moving from traditional monitoring, what we would call LMA, logs, metrics, alerts, and that's it, to a more insightful cloud-native observability. And Song, how do you see new challenges arise as we move to this more intelligent and predictive way of working?
Yeah, to piggyback on what Florian said, there is an inherent complexity that gets involved when customers or companies go to cloud native, right? Because you're operating at a much more, I'll say, distributed kind of scale. There's complexity in obviously microservices and Kubernetes or containers, but inherently that I think ends up seeing some patterns that ultimately companies that we've worked with here at Chronosphere have observed over the course of the last, I'll say even the last few months, right? There's always tool sprawl. There's always this, hey, we've landed here, and it's almost a reactive state because over the course of whatever years, they have usually a hodgepodge of tools to do one of, many things. And that might be even more exacerbated by lines of business, multiple teams, depending on how large the company is. So I think the CNCF did a survey not too long ago, and most companies will have anywhere from up to 15 disparate tools. Right. So it's a little bit of, hey, where do we go and what can we actually use when we're adopting cloud native? So just before this call, Nim had actually said my favorite word, shifting left, right? When you go cloud native, I think companies need to really start thinking about the shifting left of observability, not just security, in terms of, hey, as we roll these new architecture patterns out and true cloud native, how do we want to account for observability? Because you're going to have, again, a very dynamic ephemeral environment. And it's going to emit orders of magnitude more observability data. So how do you know what's valuable, what's not, and how do you manage all that? So that's one big area. And I'll say this, the other change, especially coming from traditional monitoring to observability, we find that a lot of companies will also have this change management, even around skills and knowledge, right? So it's hard to find experts in observability, much less if you have a team of, monitoring experts, in a NOC. I don't know if anyone even remembers what that is anymore, but having to reskill them to kind of operate as SREs, that's a huge amount of effort that we see with companies. So I think those two things end up being, the tool sprawl, how do we make sure it's the right tool? And then ultimately, how do we make sure we have the right skills and the right people aligned to, leveraging potentially what some of those tools are.
Yeah, that's very correct. And we are going to dive a bit more in the kind of the skills gap challenges that arise. But before we go there, since we are in the part of cloud technologies as enablers of transformation, I know, Nim, you through ThoughtWorks, you've worked with a lot of different cases where you've seen large-scale transformations, application modernization. I know you have some great stories to share. What role and what kind of acceleration or complexity have cloud native technologies brought into the game?
Yes. Organizations, when it comes to like, why do they even bother with transformation? What is the business need that is coming forth? And why does application modernization, why do it when you already have an application that's running maybe? But the thing is, industry changes. There's a lot of evolving needs. So there's a need for change. But you're slowed down. Slowed down by what? You're slowed down by your past decisions. Those might be past decisions on features that you chose to implement. It might be past decisions on the technology choices you've made. It may be the past decisions on how you chose to organize your code structure and organize your teams and so forth. Well, from 1970s, the Harness article talking about modularity continues to come forth in our technical industry in one shape or another. Today, and for the last 2 decades or whatever, it has been around microservices as a way to think about modularity. And then cloud native technology as a solution towards building microservices. And so once you start thinking that way and you're breaking up things, you start inherently having an evolvable architecture. So then when technology choices do get outdated, now you can say, okay, this team and this microservice, let's evolve that, let's upgrade that. The other ones can still be legacy over time, will change at a time, as opposed to one, big change all at once type of thing. And so, so you're starting to think of a more flexible architecture. You're also starting to move away from monolithic thinking. You could have a modular monolith for sure, but you're then having logical boundaries inside your monolith. Soon as you start thinking microservices, now you have these independently deployed applications with physical boundaries. And then therefore, Florian and others have said, right, the scalability, the flexibility becomes inherent. You have a technology now that is working with you and inherently has those scalability, flexibility, resilience, the ability to move with the speed that your organization needs. So that's how it all comes together. And then the whole transition and the transformation, yes, it's we talked about skill sets and needed there too, but the thinking is changing with it because the DevOps movement that companies also start to embrace when they embrace cloud native, everything from infrastructure as code, right, to cross-functional teams with SREs embedded and things like that. So that type of way really helps collectively transform the organization.
Yeah, and I think this kind of modularization that is causing a growth and kind of a rise in us thinking more in terms of domain-driven design is also a tool that kind of engineers can start thinking more of the business, right? Do you see that as well?
Oh yes, definitely, George. So one of the maybe we'll talk about this later too, but like domain-driven design is a way, yes, to connect the dots to the business in order to try to design your boundaries, your physical boundaries, to align to business needs. There's a lot of knowledge out there, a lot of practices of how to apply domain-driven design to your organization, because the worst thing that you want to do is really create all these microservices that are so tightly coupled. So you have one microservice that has all the information about your customer. And now everything through all the other microservices need to go to the customer to get that data. May not be the right way of thinking about designing your services. And so it's more about, okay, well, what's the customer journey, for instance? And, this is where they are registering. This is where they're eventually purchasing. This is where they're viewing the catalog. And so the customer is there in each and every place. And so that type of, there are some anti-patterns that are published out there of don't think about entity-based microservices, think about the functional and job and business job needs microservices. So yes, George, yeah, exactly. So when we move to modularity, think about there's a lot of helping the organization also think through what those boundaries look like, because otherwise you're going to continue to be slowed down, and you might be slowed down even worse. Because it's one thing if you have a large code base and then you could still make all these, pull requests or whatever to just update the code base in one fell swoop. But now, if you have to make changes to 50 microservices, that's really going to slow down just because of one business decision change. So yeah, no, great point.
Perfect, precisely. And we're just 4 questions in, and we've already mentioned 3 or 4 times the needs for different skills when this happens. And I know, Florian, when a startup is growing, we want to have the right people, the right skills. And I think in CTO's minds, it's probably one of the biggest challenges there. So what are the challenges you are facing when hiring, and kind of skills gaps, or even having to upskill, cross-skill?
Yeah, I think so. It's important there to think about what kind of skills are we talking about, really, because actually the hard skills of like knowing the technology that you're working with when it comes to cloud native. I mean, all the cloud providers have something to sell, and they want you to be up and running in like less than a minute with a lot of these. Like, you want a database, you want a queue, you want a load balancer. I mean, you're up and running very quickly. And so these skills are not really that difficult to get. And actually, most people would just, like most developers, would be able to just get up and running with them. I think one big skill is knowing what not to use, because this is definitely one of the biggest mistakes that I've seen, is just people just going all in, whether it's like one small startup, and I'm not talking about like a company that's like 15 years old, I'm just like less than a year old, and they have cloud functions, they have a Kubernetes cluster, they have some dedicated instances, and then it's just like, it's very difficult to provide some clear deployment processes and quality control when you have this kind of like heterogeneous environment. And I think what's really important is like seeing how different things fit together, really focusing on the architecture, focusing on the boundaries between the different systems. And yes, I think this name, what you mentioned about focusing too much on entity-based services is not really useful. And I think that maybe thinking in terms of like new architecture patterns, for example, event-driven setups can really provide some really good way of integrating different services together. But that's a very different way of thinking compared to just having REST calls between each service. And I think also one thing that's really key is not to look for just a full stack developer who knows everything from front end, and before it used to go all the way to like back end, and now we just include Kubernetes and etcd and so on. I mean, yes, some people exist that have all these skills, but you're not doing yourself a favor looking for, especially for that. And so I think what's really important is looking for people, especially in DevOps position, for example, who can really have this kind of, not only what they're like the stuff that they're managing, but the interfaces that they're providing. So the platform engineering really plays a big role there into enabling people to create interfaces and really treating infrastructure as a product that you're providing to your users, and the users in this case are developers. And that really means that you end up with skill requirements that don't go all the way through the stack. I mean, you want to make sure that things are understandable, visible, transparent, but it should not be everybody's concern of like how everything is built down to pretty much the storage level.
Okay. And talking about skills, whenever we talk about skills in the cloud native space, I remember, kind of those job ads that require 12 years of Kubernetes experience, and then you just remember that it hasn't been around so long. And we see that especially when we're talking about kind of staff plus roles or architects. And Lais, how difficult it is for a really experienced engineer to start in the cloud native space?
Yeah, I really second a lot of what Florian just said. Like, I think the hard skills, it's obviously there's so much content, just there's a lot learning opportunities everywhere. So I think that's not really that difficult. But what I think what I think is really important, and I think that's something that changed also when we talk about working more in the infrastructure related kind of space. I think there is like this changing in a way that we see the software that is written, like the infrastructure as code. I think there's a need for more system and software design to play in that area too, because like to shift a little bit from like this script based, or let's just write pieces of code to kind of glue like this big thing together. Everybody obviously thinks a lot about this when writing the business logic, the application code, but everything on the infrastructure side, we have to apply the same principles, like designing good software that is maintainable, testable, like the high quality. So I know that it's difficult to find this, like that, as Florian mentioned, like it's not maybe ideal to think of like someone that will have the experience and knowledge to like the really full stack from front end to every part of the stack until the infrastructure. But I think this like very base software development skills are very much necessary, because I think what changes a lot for people that are going to join this, I think it's really the focus a lot more on infrastructure as code is bigger, I think. There are obviously also other changes, like I think there are different ways to build the stack. One is more like the shelf products, like you just cherry pick a bunch of stuff and then you just integrate them together. But I think there's an increasing need of just building more custom code to kind of orchestrate and have everything kind of working in a way that makes sense. And we'll talk about this later too, but like it can get really complex, the amount of tools and things like present in the stack. So yeah, I don't think it's really that difficult. I think it's more like, I think being open to play a different role, maybe, because I think some roles were just very specific in the past, like, or you were like a system administrator, or you're the architect, or you played this very narrow specific role. I think having like a broader view, even though if you're not going to play the role from end to end, but like having a broader view, understanding how the software development lifecycle works, and collaborating with the other team members with different roles. I think that's really important.
Thank you, Lais. And indeed, we saw this last week that the CNCF, we got out the CNCF 2023 report, and just the number of projects and the number of contributors, like thinking that there are 173 cloud native projects in the CNCF just gives you a picture of what the complexity, of what the scale of complexity is, and how hard it is to start understanding what's happening there. I'd like to take a moment to remind the audience that we are going to be here after the panel to answer questions in Slack, but you can also use the Zoom Q&A functionality, so we can also answer questions in real time. And as we're talking about cloud native adoption and kind of that complexity, we understand that this is not just about starting using Kubernetes or containerizing 3 services. It's a very complex, multi-year, multi-departmental effort. And I really like in our previous discussion, Song, you mentioned that the need to measure these projects as we go, and the complexity of measuring the success, because it's kind of hard to measure the success of these type of projects. So do you want to elaborate a bit more on that? How could we measure the success?
Yeah, sure. There's definitely a pattern we also see with a lot of companies where because these are multi-year, multi-team, and very complex undertakings, there's kind of a lack of alignment or understanding around business outcomes, like what outcomes and results and things. And it really comes down to the why. Like, why are we doing this as a company? What are we trying to achieve, right? So it's simple to say that, but it's actually very complex in terms of, hey, is it revenue growth? Is it differentiation in terms of competitive advantage? Is it making better, developer productivity? Because, hey, we don't want our developers to toil and have all this cognitive load trying to, operate in environments where it's all about incident response and triage and just in a reactive state. They should be high value, contributing in terms of, again, building the apps and services that are going to differentiate. So I think it's really that alignment. Too often we see companies where they operate in silos, right? So the technology teams, the SRE teams, the engineers are always, hey, we need to go find the best product, but why? Well, for these technical reasons. Okay, but then you ask them, how does that connect back to the business? And often it's, some blank stares and, well, we actually don't know. So I think it's really important as one of the measures is, the business outcomes are well understood. And I love what you said, right? Because it's so complex, like one of the measures I always find is it well documented? Is it well understood? Not just the business outcomes and the pain, but ultimately, why we've created this process or why we're changing this or why we're using this tool, right? If something's well documented, then I think it shows that there's a command and control and understanding of like why this is happening. So like that to me is usually a very good hallmark. And I do think because teams usually operate in silos, how well they communicate and kind of articulate those business outcomes is usually a very good indicator, leading indicator. I'll say the other measurement is, you can always have quantification, also qualitative metrics, right? Both leading and trailing. And I do think agreeing to what those things are is really important as you kind of roll out with the strategy and kind of go through the project. So, I find that companies that invest in like a TPM function or have, a role where they are doing the program management and the project management, like that's super critical because that's kind of the glue across all the teams. And they're able to, again, kind of communicate what those outcomes are and how companies are progressing to that. So, my statement here is not so much about here are the very specific business outcomes, but having, I think, a framework around how you want to understand that, it's well communicated, and then also how you manage and show the progress against those outcomes.
Okay. So I think never forgetting the why and making sure that the metrics remind you the why, I think is a good high level way to do it.
Better said than me, George. I appreciate that. Yes.
Cool. Thank you, Song. And kind of talking about this infrastructure complexity, one of the most modern movements we've seen towards an organization adopting DevOps principles is the rise of platform engineering, standardizing infrastructure, standardizing the tooling with internal developer platforms. And my question there, Nim, is how does that play along with cloud native tools? How do cloud native tools enable platform engineering, or what do you see there?
Yeah, so I'd say that, well, some organizations are very large, might have multiple clouds. So it's a poly-cloud environment. Some may not have that, so it's a single cloud. But the thing is, it is because the infrastructure is complex, because the infrastructure is something that people are still coming on board to. As you said, platform engineering is needed. And one of the things I want to also call out is that it was interesting because Florian was saying, hey, there's a need for specialists now and infrastructure engineers. And Leis, I thought, was also saying, hey, you have to, as engineers, you want to be able to learn different skills, right? Which in my mind is like, oh yeah, there's a little bit of that going on. Now, at the end of the day, how good your platform is will really indicate how you're going to be able to be self-efficient as a team. So it's very important. Now, the thing is, especially if you're in a poly-cloud environment and whatnot, really treating that platform as a product really comes into play. And I think someone had said, right, just your developer is your consumer as well as your end business user as well. So a lot of these things get encoded into the platform. Developing starter kits that people can team members can use. What I find is that some of the cloud native tools that are out there, the starter kit. So for an organization, you might create an abstraction layer like a starter kit that then allows, and then there's a platform team that's building that then allows developers to not necessarily need to go directly to some of the cloud interfaces, especially if you're in a polyglot cloud environment. Otherwise, leveraging Terraform and all this infrastructure as code is also part of that. But still, what are those guardrails that as a platform team you want to encode into the platform so that these cross-functional teams with their embedded skill sets still have not just autonomy, but bounded autonomy. Bounded with things, and the more that you can encode your boundedness in automation, that's going to allow your teams to be a lot more efficient rather than needing to learn all of these different skill sets, right? So we're trying to really lower the barrier of being able to leverage these cloud native technologies through that.
Thank you, Nim. Some great points there on kind of how these come together and how they standardize. Florian, how do you see those two playing together? I see you wanna add something.
Yeah. No, I think Nim, you were absolutely right about this. Pretty much the importance of this abstraction, and I think and also the importance of using infrastructure as code, or like various tools that enable us to make this tangible. Because if we just have an agreement and a document somewhere that says we will use these technologies, I mean, that's all great. Nobody reads documents. And then if we have something that, we have good established processes for like pull requests and these types of processes that really work well, that have proven themselves, and if we can allow these types of processes to be used for talking about like how does this platform work, and really focusing on these kind of, you want to have an abstraction, but you want to have an abstraction that works at multiple levels. So you need to have an abstraction, something that I just want a new project, you use it, it works out of the box. And then you also need to think about what are the things that will vary between projects that I need to make sure these should be options, making sure that these options are also tested, and then also saying what are the things that I don't want to enable, and this boundedness is really critical. And I think that also having these types as well, these structures defined as code means it's also possible to use some kind of like internal open source development model where your users are able to give you feedback and able to say, I think this should be an option, and here's a use case, and really having this kind of interaction between the people who maintain the platform and the people who actually use it. And I think that these types of dynamics can really be great. And personally, I'm a huge fan of this internal developer platform concept. I've been working pretty hands-on with one of our DevOps teams before this concept existed. And when a colleague told me about this website that pretty much codified everything, I was like, thank you. This explains everything that we've been trying to say and to communicate, and just having it all in one place, and just having a shared understanding of what this platform engineering is really a blessing.
Thank you, Florian. And staying just a little bit longer on the topic of complexity and this huge landscape of multiple tools. So we see this huge number of cloud native tools, the complexity in our stack growing. As a result, we have multiple dependencies, different tools, different libraries. Lais, how do you see in especially even more so in regulated industries, how do you see implications when it comes to security, compliance, and so on?
Yeah, this can get really challenging. I think everybody already mentioned. I think Florian mentioned, Nim mentioned, and Sean also mentioned. It's very important. I think the need of a platform team to kind of have to build some standard and a product that developers can use and build things on top of. It's really important. Yeah. So I think losing control of what's part of the stack, it's a big risk, and nobody wants to not know what's going on. So I think governance, it's really important, but it doesn't have to be like the old governance, kind of very strict and yeah, I think then that's where the platform team plays the role of creating the standards and having the guardrails, as Ning mentioned. Because then we can minimize the risks and make sure that all the things that are really important, that they're going to be present. If you want to have like monitoring and logging and access management, all the security controls, everything that it's needed, you can make sure like the platform teams will deliver those things as a product that others can build on top of. So I think this is really mandatory. One thing, I think, talking specifically about the highly regulated industries like the financial industry, I think picking vendors can be a challenge. And like there's, I think, this translation gap in between what developers and engineers are building with how do we communicate this to the regulators, right? Like there's this translation gap that it can get really complex because sometimes they're speaking different languages. And I think what's important there is for us as a technology industry not to be like frightened of doing something new or using a new technology because, oh no, we're not going to be like, they're going to say no to this. We're not going to be able to run our software with this because this is not safe enough or it doesn't have this security, whatever. So I think it's also important to work really hard on trying to ask the whys, like, why is it like this? What is it that the regulators are expecting to see? So we can make sure that we actually have what's required, but then we can also work on the translation layer so that we can benefit from all the good and modern stuff that the industry has been working on. And not just sticking every time to the old technologies. So yeah.
Great, thank you, Lais. And I want to go back to Nim, to something you kind of mentioned before, that about this journey of modernizing our stack and also breaking down our services and adopting cloud native architectures. One of the reasons we do these moves has to do with moving faster, being more flexible, being more scalable, remaining agile. How do you see cloud native architectures affecting our whole SDLC, our whole life cycle of development?
Yeah, so I'll say that, so if we just step back and think about software development lifecycle and also how that's changed, right, over the decades, where there might have been more waterfall thinking and now just agile ways of doing things. Some things we do shift left, some things we actually shift right. And, you know, the things that we do shift left are, yes, we try to codify as much as possible, like security and compliance, like Lay said, right? Shift left on security, and also do whatever you can to be a no-brainer for our developers and let them, because there's a lot of cognitive load. I think if anything from this panel too, right, we're hearing there's a lot of things for developers to understand. And so the cognitive load is increasing. So the more you can shift left on codifying, the better. So that will help in terms of the software development lifecycle. But the other thing in shifting right in some ways is we don't take all of that time to let's understand, let's talk to the users, let's make sure we validate everything. No, we try to do more in production because now things are more agile, more flexible. We can respond more quickly. So things like leveraging feature toggles and A/B testing, that's a change of working, right, for developers. Canary releases, blue-green releases to also make changes, and see live responses and see what's happening. That could be a technical feasibility change. We want to just see how does it scale. So we do canary releases and stuff like that. So, and maybe doing chaos testing and things like that in production rather than all of this upfront testing in that regard. So I see these types of things like codify whatever you can in the platform, shift left on things there. But then the other thing is a shift in mindset. Let's be agile. Let's try to, and what happens in production is very different from what happens in interviewing users, in designing things on paper, right? And so that type of instant feedback and response is valuable, is how I would see that.
Perfect. Thank you, Nim. And before we go to our last question, I would like to remind the audience that you can use the Zoom Q&A feature to add your questions that we can answer here live, or we can head to Slack right after. So my last question has to do with something we didn't touch upon, but we see rising a lot, and that has to do with FinOps. We've seen some great works by the FinOps Foundation lately. We've seen companies becoming more and more cost conscious and trying to manage as they go through this transition to manage their cloud spend. And it's really important to make sure that we bring those business metrics like cost attribution, like revenue growth, or anything like that, bring those metrics to the teams and tie those with our products and with our development. So Song, this question is for you. How do you see these metrics being connected with engineering teams and being tied with cloud native adoption and kind of tying them with the success metrics of these transformations?
So we see, especially with the adoption of cloud native, right? I mentioned a few minutes ago, it's an order of magnitude in terms of explosion of observability data, right? Metrics data, trace data, like logging has been I guess a problem for a while now, right? But if you think about what companies are dealing with, it's a struggle around kind of this cost to value equation, right? So just because you admit more data, does all that data, number one, have all the same value to me? Number one. And then number two, I'm now paying potentially for storing all that data because, I think there are other observability solutions that charge based on like consumption, right? Or ingest. So I do think that there's kind of this like cost to value equation, and it kind of goes out of whack. So we find that a lot of companies are looking for, hey, how do we optimize this? But also it starts with getting a better insight and kind of understanding of what data is valuable, what observability data is valuable, right? And then also then being able to do something with it. Just because you have all the data doesn't mean it's going to solve all your problems. And Nim, I love what you said about cognitive load. Less is more in this case, right, for developers, because when something's broken, like they don't want to have to sift through tons and tons of stuff. Show me everything in the context of this incident or outage that I need to know, whether I'm a junior developer or a power user, right? Senior SRE that knows everything inside out. Like surface up to me so I can quickly understand, diagnose, remediate, fix, and then document for the future what that is. So that comes as a function of, again, being able to understand what that observability data is. So I think there's a lot of focus with companies to make sure that they're only keeping what they need, understanding it, but then also having the flexibility, right? So this is why I think we have 173 or so projects, right? Because there's a lot of optionality that customers are still looking for. Companies want that optionality, and leveraging, open source, but also open standards is critical, right? And I think this is where the market is going. This is where companies now have more confidence that these projects have kind of that business, I'll say, enterprise readiness, because now, you see some of the more laggard kind of traditional enterprise companies starting to adopt these things. So I think that, the cost equation then becomes much more acutely kind of manifested in, hey, do we even understand what we're paying for? So like we see that, and, shameless plug, this is like our whole value proposition for Chronosphere is to be able to understand and, provide that insight and that granular control of what you see, and then ultimately what you persist and store for developers to basically have at their fingertips when things go wrong, right? Or even ahead of things going wrong. So I think that, again, tied to those, I'll die on this hill, like the understanding the business why, this is it, right? Like all the technology is meant to enable and support, hey, we need to make sure companies who have their apps and services as their like first line of revenue and kind of the experience for, users, like it's becoming even more hypercritical that they're available and performant and are able to kind of meet the customer's demands. That's why they adopt cloud native. So ensuring that your cloud native environments are up and running and operating in health, like that's, I think, the key role that observability kind of plays in that for companies. So that's my 2 cents, George.
Perfect. Thank you, Song. And I would like to jump on a question that is, I know we are close on time, but this seemed pretty similar to both kind of FinOps, but also what we were saying before about tying kind of how DDD brings domain knowledge to our engineers. So the question from the audience is, do you see developers becoming more economically savvy with their code implementation? Like reduced network usage, more efficient logging, and so on, as a result of the cost of cloud native platforms. And in that I add, and also as the knowledge we kind of bring to them from the business. And Nim, do you want to take that one?
Yeah, so I was going to say yes, definitely. I have seen that, but only if it's done well. In that we give team specific feedback. It goes very well, and with FinOps and the cloud native technologies, you're able to label, in APM systems and things like that, like which team contributed to this usage of the cloud. And there's a lot of there's research also, right, that as soon as you start showing, for instance, even a user in a household how much energy consumption they have, the house energy usage goes down where you can. It's that type of thing. So that feedback, and with anything, and we talked about software development lifecycle, the feedback loops are very critical, and the observability platform, as Sung is talking about, FinOps feedback loops, user feedback loops, all of those are critical to it. So so I think as long as you do it well and you're able to connect the dots for developers, that this action I just did, this code change that I just released to a prod in a canary release or whatnot, is now causing this cloud cost change. That type of thing is good as well. So
Thank you. Thanks, Tim. I think we can do one more. So we talked a bit about the skills and how senior, like the staff plus engineers can go into the cloud native space. A question that comes up a lot is, how can junior developers, how can new engineers go into that space? So the question is, do you think cloud native systems are harder for junior developers to understand, since many design decisions are made based on restrictions imposed by the environment? Florian, do you want to take that one?
So I think, yes, there is definitely like a huge complexity, and just like I'm not sure what it must be like to just like enter this field, and there's just so much you need to know. At the same time, I think due to the fact that it's very easy to get started, even if you previously, like if you wanted to get a server, I mean, it would be something expensive. You didn't get a server just to play with, or that was a luxury. Now, for example, with like cloud functions, like anyone, even with their personal account, can just get up and running and start trying things out. And I think that this is really something that makes it a lot easier for people, especially juniors, to get up and running and have something that works. Of course, the type of infrastructure that you build up, like with something like this, will be very different from the type of infrastructure that you have in a large organization. And I think one of the key things that often gets left out at the start is exactly this observability. And to give another answer to the previous question, where Nim, you said, yes, people are more economically savvy. I would say yes, if they do see the impact. And the opposite, I've also seen like some developers who cause like a lot of costs in logs, because they just thought, oh yeah, we'll just log this one object, and it just gets logged as JSON, and suddenly you have like a huge amount of data that gets logged over and over again, provides absolutely no value. And if you don't have an eye on this, then this turns out to be really expensive. So making sure that there's also these kind of structures, that really surface the information about how your system is working. I think this is really useful and really key, also in terms of getting people who are less familiar with the system and just showing the right data at the right moment, and really providing like, yeah, these insights. Simple things like you create your pull requests. When you merge it, it shows you your thing was deployed, it's accessible here. And not like it just makes it so much easier to navigate things, and that really improves the developer experience for everyone, but also for the juniors who might not know where to look for that information.
Perfect. Thank you for the insight, Florian. I'm really happy. I feel I'm already smarter, and I gained a lot of knowledge during this panel. I really like Lais's opening about cloud native making it possible for large enterprises to adopt microservices. I think that's a really good point, and that addresses heavily the why. As I also think we kind of addressed that, of course, it comes with an inherent complexity, and the complexity can be in skills gaps, compliance, security, financial complexity, and also the danger of over engineering. If it's one or three developers, they cannot build an app and also manage Kubernetes clusters and a lot of tooling around there. So it's not one size fits all. But going back to Song, remember the why and build metrics and visibility around why you are doing this and track the progress. And that's what's gonna keep your eye on the ball. And with that, I would like to thank you so much for the great insights in today's panel. Now we are all going to be heading over to the Lead Dev Slack in the technical strategy channel, and we're going to continue this great discussion.